Ich habe zwei echte Schwergewichtler der HiFi-Welt interviewt. Derek Hughes und Paul Graham. Die beiden stehen für eine besondere Philosophie im Lautsprecherbau, geprägt durch die Forschungsarbeit der BBC in den 70er Jahren. Ziel war es damals wie heute, Klang so unverfälscht wie möglich wiederzugeben. Bekannt als Thin Wall Principle. Derek Hughes war eng an der Entwicklung der klassischen BBC Monitore beteiligt. Paul Graham bringt über 20 Jahre Erfahrung aus der Pro-Audio-Welt mit und verfolgt konsequent den legendären BBC-Sound. Aus der Sorge, dass diese Lautsprecher mit der Zeit verschwinden, entstand die Idee, das Erbe mit offizieller BBC-Genehmigung weiterzuführen. Gemeinsam entwickeln sie Lautsprecher mit dünneren, kontrolliert schwingenden Gehäusen und präziser Dämpfung. Für mehr Natürlichkeit und weniger Verfärbung. Wir haben die beiden auf der Klangschlossmesse getroffen, im Raum von AudioSense, und sprechen mit ihnen über das Thin Wall Principle und seine Bedeutung bis heute. Wenn ihr mehr über AudioSense und Graham Audio lesen möchtet, habe ich den Link für euch in der Videobeschreibung. Und interessiert ihr euch generell für Audiothemen, dann abonniert jetzt meinen Kanal. Viel Spaß mit dem Interview. What exactly inspired the study back in the 80s?
Necessity. The BBC, like most broadcasters, was always after improvement and using the technology to communicate what they've got to do in television or radio. And so they're always after technical improvements, and loudspeakers are very key, because obviously the only way that an engineer knows what's going on the other side of the microphone is through their loudspeaker. And as new materials became available, new techniques, they developed from about the 1940s really is when research started seriously. And in the 1950s and 60s is when the major developments that we're drawing our loudspeaker designs from in that period. So it was always the pursuit of not perfection, because you can't get a perfect loudspeaker, but of sort of attaining the best possible technical answers to monitoring.
Okay. So when you had this license, so back in the days, can you just tell us how many manufacturers like Graham Audio did contact you to use this license? How can we imagine this happening?
So I wasn't involved in licensing in the BBC. I was an engineer in the BBC. Licensing is a totally different thing.
Okay.
So when the BBC did these designs over the decades, they then licensed them, because obviously they don't have a manufacturing capability in-house for large numbers. So they put them out to license people like KEF and Rogers and such like that over the years, and Spendor that I used to work for as well. And then Paul turned up on the scene, didn't you?
That's right, and I bought some licenses from the BBC to pursue what had gone before. Because there are a lot fewer people licensing the BBC speakers these days, because everyone thinks they can do it better themselves. So, but not for us. So that's why I got the licenses, which is how Derek got involved, because I needed someone to be able to pursue the project, to be able to develop the speakers from there.
Can you tell us a little bit more about Graham Audio and its philosophy?
Well, what happened with Graham Audio, I had a company and we used to buy a lot of used audio equipment. So the BBC were a very rich source for that. And as we were buying more equipment from their studios, what became very apparent was when we sold the equipment on, the loudspeakers were very, very popular. And eventually, I bought up all the BBC loudspeakers. There were none left to have. So I thought, well, if there's such an appetite for people to want these loudspeakers, I'll approach the BBC and see if they'll grant me a license, which they did. And that's how I got into it. And it was purely because of buying second-hand equipment from the BBC.
Okay.
So that's how we arrived at the conclusion, then hence meeting Derek to be able to build them for me, as it were.
And after you got the license, can you tell if the sales become more after that, or the interest of customers?
No, certainly.
Yeah.
Because the original ones that we were buying from the BBC had been around for a lot of years. They were very poor condition, but people were still paying quite a lot of money for them. So we thought, well, the likelihood is if we start manufacturing them, with the cases being sort of, well, as new, there's likely to be sales on it, and it's gone very well. It's a niche market because they're very expensive, but no, it's gone from strength to strength over the years. But you know, because we are a very small company, but no, we do okay. Cool. So, yeah.
How is the research from that study still manifesting in today's speaker design?
Because the fundamentals that they investigated were, valid scientific principles. I think with anything engineering, if you establish a good scientific principle behind a design, you can apply that over the decades and across different models, which is what the BBC did and what we do. So there are certain principles that refers to the thin wall damping, which is the famous one, which the BBC developed to meet a specific need of weight and portability, cost and quality, a mix of those things. And then we apply that from all the different models that we make. But this was the first one that Paul had a license for, the LS59. And then we've gradually worked our way through all the available models of the BBC, with one or two exceptions, over the years, haven't we?
We have.
Yeah.
But the BBC's idea, I think Derek will be able to expand upon this, was that they were reference monitors. So the loudspeakers would sound the same in London as they would in Glasgow. So it was always referenced back to an original, I think it was an original speaker, wasn't it?
Yeah.
So you knew whichever studio you went into, it would sound the same. So that's what we've tried to carry on.
I actually own a pair of the Rogers LS35A myself. From your perspective, is there a significant sonic difference between my Rogers and the LS35A from Graham Audio? Kurzer Hintergrund, wieso ich diese Frage gestellt habe. Denn mein Gedanke war, wenn alle Lautsprecher, welche BBC-Lizenzen nutzen, denselben Prinzipien folgen, müssten sie dann nicht alle absolut gleich klingen und auch preislich keinen Unterschied haben?
The sound should be the same. The terms of the license, I mean, for example, Rogers and us would use identical size cabinets and style of cabinets. But the BBC licence enables you to make changes as long as they're improvements. And they always have to accept them. They have to hear them and say, yes, that conforms to our design. But yeah, I mean, they're quite tightly specified in terms of frequency response and such, and construction.
I would say, though, that our 599s will sound different to something that had been produced in the 70s.
Yeah.
Because it's what's the cone material they make?
The polypropylene they use.
Polypropylene hardened over the years. So ours will sound different to the originals because just the hardening of the polypropylene.
Sheer age, yeah.
But the responses should be the same.
Okay.
I mean, I would say ours sound better because more modern techniques and more modern materials. But in principle, they're the same.
Yeah.
What kind of amplifier would you personally recommend or use for these speakers?
I mean, from a power point of view, we specify up to 50 watts, is it, I think, for the 35A. They're a small speaker, they're not very sensitive. So you don't get much out of what you put in, simply, because they were designed to be used at close quarters. So, and if you push them outside that boundary, if you put them into a big room and try and drive them hard, it doesn't work. They're not designed for that. Which is why the BBC and us have a range of speakers from small to large, because they're designed for particular environments. So yeah, the 35A is a good little speaker. I mean, it's a very old design now, and again, we've stuck to the specifications. It's quite detailed with the 35A, isn't it, in terms of how they're built. Put it this way, they were designed in the mid-70s, late 70s, with what would now be regarded as fairly rudimentary power amplifiers to drive them. So I suppose it's conceivable that I would have said any modern power amplifier would have exceeded what they were using when they designed it in the first place, which might sound a strange answer. But if you my personal philosophy is if you've got a good, high quality, low distortion amplifier, I always use solid state amplifiers, then you're going to be exceeding the quality of the speaker itself. And you'll be really pursuing the law of diminishing returns. You put a lot more money into an amplifier, but you only get a very, very little improvement in overall quality. So there comes a point where it's not worth spending a lot on amplifiers. But I mean, any really competently designed amplifier will do fine. That's my take.
I mean, in many ways, the 35A is a fascinating story of how they arrived there, is it not, Derek? Because it wasn't designed to be a monitor. It was designed, was it 8 scale?
Yes, the BBC were investigating, well, put it this way, they had lots of big studios. And obviously to design the acoustics of a big studio is very, very expensive. So they had the idea, let's make a 1/8 scale model of a studio. And we'll test out absorbent materials, like this sort of thing. But to do that, they had to have a loudspeaker which would go to 8 times normal frequencies. So there's BBC reports about all this, very interesting. And so they had what was originally the same size box as that, more or less, was the basis of the speaker, but it worked from 400 hertz up to about 15, 20 kilohertz. And then there was a sort of, I'm going to hesitate to use super tweeter, I don't like that phrase, which went up to nearly 100 kilohertz. So they would play music at 8 times the speed, record it all, and then play it back and reduce it down so they could hear the effect of different. They'd move players around in an orchestra. They have different absorption, different seats, all sorts of things, and then they could predict what the full-size studio was going to be. So there was never an intention to make a small loudspeaker. And at the time, my father was working in a research department in acoustics. And literally, someone said, well, I wonder what this would sound like if we actually took it into the listening room and played it normally. And that's how there was never any intention. So they thought, well, this sounds quite good. Let's develop it and make a little loudspeaker, because they were using other small loudspeakers which weren't very good. So it was an accidental design, which is an intriguing history, really. So they decided to develop it to an actual finished model. Yeah.
Is there any key advice you'd want people who build their own speakers to know about the design process?
I think one of the things that I think is often a problem is the original material that people use to listen to design from. And we use mainly classical material, classical music, in other words, real instruments. As soon as you start using artificial instruments, like guitars through an amplifier, you've got no reference point for the real sound, because there wasn't a real sound. So I'd encourage that. One of the things that I've always used is a reel-to-reel tape of speech, which was recorded in the BBC's anechoic chamber of people that I knew. And the BBC's approach was that speech, our brain is hardwired to recognise speech in great detail. So they always use speech recordings of people they knew as the foundation of the loudspeaker. And you then, so you're using speech from a couple of 100 hertz up to 8, 10 kilohertz male speech, and then you go out from there for the bass and the treble. But if speech is a foundation of the quality of the loudspeaker, then again you've got an absolute reference, especially if you knew the person that was being recorded. And similar with musical instruments. So that's the foundation. I think people make the mistake of basing their designs around listening to, I don't know, pop music, for want of a better word, which has never existed in reality. So there's no grounded reference point for what they're listening to. Okay. And I always use a mixture of listening and measuring. I'll start with measuring because that's a fairly easy thing to do. And then you go through a cycle of listening, measuring until you feel you've got the finished product.
I mean, the BBC had an advantage because of the Maida Vale studios. Again, Derek will be able to expand upon this. is that they could go into a studio on a weekly basis and listen to the band. You know, in the 60s it could have been the Rolling Stones, it could have been the Dave Clark Five. Come back into the studio, listen to it through the monitors, listen to the band, listen to the monitors, could be with jazz, classical, and then refine the speakers over the weeks or months or years. That no one can do anymore because no one has the time or the manpower to be able to do it.
Or the money.
Or the money, yeah. So in many ways we have the advantage of all that heritage, which is a great plus for us. So,
Wisst ihr, was eine Fotobomb ist? Ja, ganz genau. Eine derartige Unterbrechung habe ich meiner Kollegin Sophia zu verdanken. Aber ich bin wirklich dankbar, denn sie hat an der Stelle spontan sehr interessante Fragen aus dem Off gestellt.
What were the main innovations or materials discovered through the study?
How long have you got? As I said, it was a development from early on. The original loudspeakers used very thick solid wood, very expensive, very heavy. And then they realised that they needed to make loudspeakers more portable, better, more cost effective and better quality from the cabinet's point of view in terms of the cabinet not colouring the sound. So they went through various sets of processes with different woods and backed with different materials. And that process, I suppose, took about 15, 20 years, all in all, to arrive at what they felt was... they had a criteria of judgment that the output from the cabinet, the vibrations from the cabinet, should not be audible when you're listening to the music, because I mean the cabinet is a very large surface area compared to the diaphragm. So any vibration, you've got like 8 times or 10 times the area. So the vibrations from the cabinet walls had to be pushed down very low, not to interfere with the music. So they went through various materials. They built their cabinets out of plywood mainly, which is a good stable material, very, very consistent. And then they backed that with bitumen pads, which again produced a very consistent result. Consistency is what they were after, because as Paul said, they have to have the same sound wherever they go. So it was just there's a huge amount of information on the BBC research site about all the documentation, which I say went over 20, 30 years altogether. But they ended up with the design of a cabinet to not affect the sound. It's as simple as that, basically.
And the cone materials changed as well, didn't they? From paper through to polypropylene, wasn't there? There were a number of... was it Bextrine?
Bextrine, yeah. I mean, there's the model that their version of that used a material called Bextrine. And when they were doing materials research, they went through over 300 different plastics that they tested before they came to one they liked. So you can see the depth at which they investigated things. And then they moved from Bextrine, which is a polystyrene-based material, onto polypropylene. But the consistency was always the thing uppermost in their mind, because early drive units which they had to buy commercially weren't consistent. They varied from batch to batch. They'd reject sort of 90% of a manufacturer's send them, and they decided, no, this wasn't any good. We need to investigate our own designs and produce our own designs to a more consistent level. So that's what drove the research.
Was there a day or a moment where you felt you had reached a breakthrough?
Not really. It was a progressive thing. One of the things with these sort of investigations is that you're always uncovering another layer of problems to be solved, because that's what actual design's about. You're solving problems. You make something, you identify issues with it, and you solve the problems, and you're gradually working through. Obviously the biggest problems are the ones you hear first, so you deal with that, and gradually it's like peeling an onion. You're uncovering layer upon layer of different technical issues, and you gradually work your way through solving them. And in the process of that, you find different materials which were better than the material you had sort of 2 years ago. So it's just an ongoing process. And but the thing with the BBC is that they had a tremendous group of engineers working with. They just gave them a project. Go and do this project. They didn't have budgets. They just had a group of guys who would solve technical problems for them, which you just don't get these days. But so that and there were certain individuals through that period who were very, very clever engineers and were the sort of foundation of the research. But it's a gradual process through solving issues and.
Still a room for improvement, you'd say, or Graham is the perfect.
No,
well,
nothing.
We would like to say that, but
no, nothing. The loudspeakers are by far the most imperfect part of the audio chain. Imperfect. Oh yeah. I mean, hence my reticence about amplifiers. Because I mean, the weaknesses in loudspeakers are 100 times the weaknesses in any amplifier you care to mention. So you're solving a whole, and it's not just one. I mean, with electronics, you've got electronics problems, yeah. But with loudspeakers, you've got wood problems, you've got radiation problems, you've got magnet problems. There's a whole host of things. And one of the things in a research department, they looked at this, and the engineers asked their mathematician and theorist, how do you think we'll ever solve all these problems? And he went away, and this was about drive units. He said, well, I think there are about 300 variables here, only 100 of which we can measure accurately. Right. So that's the degree of uncertainty, if you like, in a design. So you're always, I find it hard to listen to loudspeakers because I just hear all the faults, however good they are. And you're always chasing imperfections and how to overcome them. So that's an engineering approach. Yeah.
I mean, I don't think the 5.9s, when they first appeared at the BBC, were well liked, were they?
No,
because
they weren't. No.
They scrutinised the material so heavily that if a recording's very poor, it shows it up. So people then blamed the loudspeaker. So, well, the loudspeaker doesn't sound very good. Well, actually, it wasn't that. It was the recordings were not very good.
Yeah.
So as recordings improved, the speaker sounded better.
Yes.
So,
how did the two of you meet?
No, I mean, Paul had this licence for and didn't know me at the time. And then a guy in the BBC who was partly responsible for licensing saying, because he had some issues trying to get someone to design this thing. He had the licence, but, not the technical know-how, due respect.
That's right, no, of course.
And so this guy, Mark, said, why didn't you contact Derek? So I just got out of the blue this email saying, I'm Paul Graham, I've got a licence, can you help me? Yeah, fair enough. Yeah. It was as simple as that.
And 15 years later,
15 years
still
later, yes.
Are you currently working on a project together that you would like to highlight?
Yeah, we're doing a couple of things.
A couple of things at the moment, yes, yeah.
We're doing a field call loudspeaker.
Yeah.
And we're also doing a small coax speaker in development. Yeah. Which are not BBC. The field coil, just because we're interested in doing it.
Yes, that's right.
These are not BBC associated. And the field call, I don't know whether you know what field call loudspeakers are, but basically the coil is driven by electricity. I think Derek can answer better than I.
Yes, rather than, it's a very ancient idea really, but it's a more interesting thing, isn't it?
It is, yeah.
In the old days, even before my time, magnet materials weren't very good, and in radio sets with valves and stuff, they instead of magnets, they had a coil of wire in the loudspeaker to energize it magnetically. Obviously, magnetic materials improved, so that fell by the wayside a bit. But in the last few years, there's quite a few people that have been investigating field coil designs. So we decided to have a go at it, didn't we?
We did.
Yeah,
well, because it is more consistent ultimately.
Yeah.
But how much of it you'd be able to detect is arguable. Yeah. But we just thought we'd have a go at it.
Well, so yes, interesting project. Yeah. Yes.
So so those are things we're having a go at the moment. Because we've run out of BBC speakers.
We've run out of BBC speakers, yes. Yeah, but we also, although we've got a BBC range, we've also got some others, intermediate speakers. Between the LS35A and that, which were the first two, we designed a medium-sized speaker, which wasn't a BBC design, but it still embodies all the same principles. That's quite successful, isn't it?
Oh, very successful, yeah.
So there are some of our own designs in with the BBC designs as well. Yeah.
Okay.
Do you have a song recommendation for the community?
Oh, again, that's a very, very difficult one. I mean, for reference, we use is the Michael Jackson. Is it Beat It or Billie Jean? I think it's Billie Jean, because we just know that tune so well. So you listen to it and you know if something's right or wrong. Not for pleasure, it's just a question of, we started with that when we do, because all our speakers have a sine sweep. So every speaker's tested, so put a sine wave through it, tested, and at the end it's always listened to with some acoustic material. And I think it is Billie Jean that goes through. But whether I'd recommend that is a different matter. It's just that everyone in our tiny factory knows the tune so well that you know where the snare is, the claps, the hi-hats. You listen to, you think, no, if that's close, we know it's right.
The other one which I like is a Jennifer Warnes' Bird on a Wire, which is a Leonard Cohen song. And there's a famous Blue Raincoat is the LP, and that's a very nicely produced song. You know, I like that one.
Is it a Leonard Cohen song?
Yeah, I
It
believe
sounds a
so.
bit cheerful for you.
Well, yeah, he was in a good mood, obviously.
He
Yeah.
was in a good mood that day.
Super Chance, mit den beiden Herren einfach mal persönlich zu sprechen. Und ich finde, daraus ist ein echt interessantes Gespräch entstanden. Ich hoffe, das Video hat dir gefallen. Wenn du den gesamten Vortrag von Derek Hughes zum Thema BBC Lautsprecher, Thin Wall Principle hören möchtest, verlinke ich das an der Stelle und auch in der Videobeschreibung. Wenn du meine Art magst und mein Engagement für die HiFi-Szene schätzt, dann freue ich mich, wenn du jetzt meinen Kanal abonnierst. Vielen Dank dafür. Ach ja, und kommentier auch gerne, welche Fragen hättest du den beiden Herren gestellt. Audiophile Grüße aus der Elbchaussee in Hamburg. Ciao.